Hi, everyone. We are going to take a look at the final Delta Math topic for this week, which is function transformations on a point. So here we go. A quadratic function's plotted on a graph. The vertex is at minus 4, 5. What's the function of g of x if g of x is f of x minus 2? Well, the minus 2 is just going to yank all of the y values down by 2. The new vertex is at minus 4 still. The x value doesn't change. But the y value is lower by 2. That's 3. Do you want to see this in Desmos? Maybe I'm feeling like it's just too simple for me, and I should maybe do something more. And I could write some notes on a paper, which would probably confuse you. But if I just show you the parabola x, wait, is it 9x? What am I doing here? A parabola with a vertex at minus 4, 5, you say. Okay, well, let's do a parabola with a vertex at minus 4, 5. So we'll do x plus 4 squared plus 5. Look at that. I got a vertex at 4, minus 4, 5. And then I'm going to call this f of x. F of x is equal to that. I'm going to create a new function. G of x is a new function, and it's equal to f of x minus 2. Oh, look at that. It just moves the function down by 2. I I'm sorry, but it's just so clear to me what's going to be happening that I struggle to explain it. Maybe the thing is that people will be confused. Well, what's the difference if that wasn't there, but instead it was in here? Well, that moves. That's right, attached to the input. Okay, because that's attached to the input, it's a D transformation, and it counterintuitively moves the input in the positive x direction. Sorry, moves the vertex in the positive x direction. But the problem we're solving is this one where it moves in the in exactly as you'd think, the negative y direction. It moves from here down to here. All right, boop. There it is there, negative 4, 3. What did I say? Negative 4, 3, okay? It's very fast visually. You learn to do these visually, like I suggest, and so they say draw a sketch of the potential graph. Great. Or just plot the vertex. Sure. Shift down 2 units. Boop, 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 boop. There you go. So you can do the long road, like they say. Get out a piece of graph paper, lick your thumb, get down to work, or you can just visualize it and be done. Okay, all right. This is the same type of problem. If the vertex is at minus 6, minus 4, and then I lower every point in the function, where's the new vertex? Minus 6, for gosh sakes. Okay, same exact thing. So let's submit this answer. Yeah. All right, let's do a new problem. Okay, so we have a quadratic function. The vertex is at 3, 5. What's the vertex if I subtract 3 from all the x values? Well, that counterintuitively moves the x values in the positive direction. All right, let's look in Desmos again. Here's the point 3, 5, which happens to be one of my favorite points. So let's move this to the point positive 3, 5. There it is. And now they said, well, we want to now translate that f of x minus 3. Okay, and I'm telling you, that's going to go from 3, 5 to 6, 5. Watch this, x minus 3 to 6, 5. Okay, how do I know that instantly? Because it's a visual thing that happens for me. I just see it move in my mind. So that's the point 6, comma 5. And your work is submitted. Yay! You're going to do lots of these. I'm going to add some practice to this. This is good practice, but okay. So now all the points go up by 2. So 3, negative 6 goes to 3, comma, negative 4, and bracket. Yeah. Okay. All the y values go up. So they say draw a sketch of the potential graph. They're being very thorough, and I like that. That's really great. Okay. And then they're going to take that point and move it up by 2. Shift up 2 units. There it goes from negative 6 to negative 4. And that's how you do it. Okay, you want to see that in your mind. Now, you don't necessarily need to graph it, but you do want to see it in your mind. Oh, I did tell you to do 5 of those. Yeah, you can do 8. Nah, 5 is lots. Let's do this one, function transformations on a point. So these ones are better. I'm going to make you do more of these because they're a little trickier. All right. So the vertex of the resulting parabola is at negative 4, 4. All right. And what would be the result here? Well, now it's going to be at 4, 2. 4, 2. Okay. And y. Okay, so here, now you're going to want to start building like your transformation points, right? So my points start out as xy's, and then they're going to go through this f of negative x minus 2 transformations. This is k equals -1. K values divide my x inputs. So my new things will be x divided by -1, or basically just flip the signs of it. And then this here, this is a C transformation. C is equal to -2. That means all of my y values will go down by 2. So I can apply this to a series of points, or in this case, apply it to the point -4, 4. So if I have the point -4, 4, and I flip the sign of the x, that's going to go to +4. And if I subtract 2 from the y, that's going to go down to 2. That's all we do there. 4, 2, and your point. Yay, no problem. All right. Oh, wow. It's the same transformations. So the x value is going to flip signs, and the y value goes down by 2. So it's -6. Yeah. Let's do another one. Okay, this one is an A transformation, flipping the value of my y coordinates. So this will go, we do that first before we do that. Okay, if you did that first, you would be doing Bedmus wrong. So don't do that. So here, first you go to -3, comma -6, but then you go up by 2. So you'll go to -4 instead of -6. Yay, let's do another. All right. So this one, again, we flip the value of the x and we lower the y by 2. You've seen that before. It's the same transformations. Why do they do that same transformation so many times? There's a more interesting one. This one is a transformation. Flip the value of y, and this is subtract 3 from all the x values. So we're going to subtract 3 from that x value. It's now 2. And we're going to flip the value of y. So it's -3. All right. Now, let's take a look at their explanation. Draw a sketch of the potential graph. Sure. Okay, fine. Or just plot the vertex. Fine. Okay, or create a transformation point and do it more point by point, which is my method. So first, they shifted left 3 units, and then they reflect over the x-axis. Okay, which is the same thing that I'm doing. One thing that I don't like about their method, but you'll notice I did this too, is that they did the translation before they did the reflection. In this case, it doesn't matter because the reflection was happening to the y value and the translation was happening to the x value. So they don't mutually affect one another. But always do your stretches and reflections before your translations, especially when you're transforming either the same x or the same y. Okay, let's look at another one here. This is going to flip the values of the y coordinates. So we're going to be at -3, -3. And then this is going to subtract 3 from x values. So we're going to be at -6, -3. Right. Okay, so this is how you do function transformations on a point. If you have questions, send me an email. My general method is I am creating a transformation point out of the different points. I'm saying what's happening to my x values, what's happening to my y values, and then applying that point by point. I wish we had more practice like this in Delta Math where we had like all 4 transformation values. We're multiplying, we're subtracting and adding, and it really tests like how accurately you can do this. Maybe I should just spring for the paid Delta Math membership so I can create my own problems to tickle you with. All right, everyone, that's enough from me for one night. As you were, send me emails with any of your questions, and thank you very much for showing up for your learning. Bye for now.